Hello, and welcome to your last statistics PowerPoint. We will be covering chi-square statistics in this one, and that is when you have to analyze two categorical variables together to determine if there's a greater likelihood of one over the other. So, again, you can only use categorical variables, and these are probability statistics. And one of the assumptions for a chi-square test is that the distribution of frequencies for the categories under consideration are equal, meaning that they generally look alike. For the purposes of this class, you don't need to worry about that so much, but you should know that information for like exam purposes. Okay, so you use chi-squares when you're wanting to know if something is more likely than something else to happen. So you're usually comparing variables that have two different categories. Males and females are common. People are always wanting to know, are males more likely than females to do anything, or the other way around. The same with undergraduate or graduate students. And then I also added an example: are students that take out student loans more likely than students that don't to engage in gambling? So the more likely is kind of the key. When you see that word and you're talking about categorical variables, you know that the chi-square is the only test that you can actually compute. The Excel formula for calculating the p-value for chi-square statistic is the equal sign, chi-test, then the range, and the range. But first we have to do a little bit of organization in Excel. So, whoops, I didn't mean to open that file. Nor did I mean to open this file. And I'll tell this, remind me tomorrow. I do have a file though. Here we go. Okay, so what I have here is the data or the worksheet in Excel for data collected on whether or not, excuse me, males or females are more likely to use Twitter. So you can see I have a column for males, a column for females, and then whether or not they use Twitter is a yes or no. What we have to do is organize this into a 2x2 box. So I made it so that there's only 15 in each column, so it's a little bit easier. We can just count it by hand. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 yeses. So Twitter, yes. Males, we had 11. And then 1, 2, 3, 4. There's 15, so that sounds right. We do the same for the females. 1, 2, 3, 4, 5, 6. And then the nose, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that just shows us our data in a table format, but you need to do this before you can compute the p-value for a chi-square test. You also need to add the totals all the way around. So you've got 6 plus 9 is 15, 11 plus 4 is 15, and then we do this to the row total. So 11 plus 6 is 17, and then 9 plus 4 is 13. And then we should have a grand total, which should be 30 both ways, meaning 17 plus 13 equals 30, 15 plus 15 equals 30. Once you have that, we can then calculate, and these are what are called the observed values, because this is what we actually observed when we collected our data. We had, just pretend I gave out a survey on Twitter use among males and females. I had 30 people, and this is the observed values. And we also have the totals, which we'll need to compute the expected values. So over here, we have to do the expected values. And the way that you're going to do that is each box will be different. But for the first box here, you're going to take the total, the column total, multiply it by the row total, and divide it by the grand total. So what that looks like is equal, and this here is B21. We want to multiply that, so we use the asterisk, by D19, and then we're going to divide that by D21. Okay, and that gives us an expected value. And I'll talk about that in just a little bit more, what that means. Let's calculate it for all 4 of the boxes. So for males, no, what we're going to do is the same thing, only now instead of using 17, we're going to use 13 because we're looking at no. So again, it's equal. We're going to take this number here, B21. We're going to multiply it by this number here, which is D20. Oops. And then we're going to divide it by the grand total again, which is D21. Enter. For females, we're going to do, they just both happen to be 15. That may not always be the case if you don't have equal amounts of males or females, but in this case we do. So for this box here, we're going to take this total multiplied by this total divided by this. So equals, and we've got C21 multiplied by D19 divided by D21. And then we do the same thing for here. So this one will be equals, again it's C21 multiplied by, now we want this row total, so this will be D20 divided by D21. Okay. Then we're going to, do we have to get the totals? I think we do. So we're going to add the totals here. And 12, 13. Then you've got 6.5 plus 5.5, so 15. 6.5 plus 5.5, 15. And your grand total is 30. Okay, so this, we always assume in statistics that there is no significant difference. Whenever we're testing anything that's called the null hypothesis, you may have heard of that before. When you are testing a hypothesis, you always assume, as a researcher, that there is no difference. So we're assuming there shouldn't be any difference between males versus females and their whether or not they have Twitter accounts. And this would be the expected values if there were no differences. I hope that makes sense. So you would expect to see 8.5. I mean, I know you can't have half a person, but we would round up. 8.5 males would say yes, 6.5 would say no, and 8.5 females would say yes, 6.5 would say no. But that's not what we observed. So what we observed is here with these numbers. And that is what we need to find out. Is there something significant about that? So we're calculating a p-value, and we're going to do it here. Equals chi-test. And we want the parentheses here, so I was just double checking in my book. Comma, and then you're going to grab the expected values as well for the second array, and then you're going to hit enter, and you're going to get a number here. I actually in advance went ahead and formatted the cell so that it would come out to a number, right? So I'm sorry, they all are numbers to 2 decimal points, but you could see it would round up. So you could do that by yourself if you wanted to. Format cells, number, 2 decimal places. Okay, so the p-value is 0.07. That is higher than 0.05. So 0.05 is always going to be the magic number that you are looking for to determine significance. So what this is saying is that there aren't any differences in the number of males versus females that have Twitter accounts. And that's probably because this sample size is so small and the chi-square statistic is very sensitive to sample size. However, you see how it's 0.07, and this is what we would call approached significance. Let me write that. Okay, and the reason we put approach significance is because you can kind of think like it is approaching 0.05 or under. If it was 0.10 or 0.110 or less, then we can use the term approached significance. And that would be okay to write up. But it wouldn't be accurate to simply state that it was significant, because everyone knows that the cutoff value is 0.05. So let's go back to the PowerPoint. And remember the chi-test, range 1, range 2, or array 1, array 2. And here is the contingency table that we constructed, except that this number is wrong. I don't know why this says 60. It's supposed to say 30. So please correct that in your notes. And then we can write up the results. Now, I've actually got a mistake here, so let me fix this. The findings indicated that males were not more likely than females to have a Twitter account. And then we can add the p equals 0.07 and add the statement. However, the p-value approached significance, indicating that there are differences just in this sample. Okay, while I'm fixing, I'm just going to go back and fix this number because it's going to bug me. Save. Slideshow. Okay, so here we are again. So here is how you write this up. The first research or second research, whatever research question it is, asked which gender was the most likely to have a Twitter account. Gender, and I put in yes, no in parentheses so we know how it was coded, was cross-tabulated with whether or not they had a Twitter account, which was also yes or no. Expected values were calculated, and a chi-square statistic was used to test for significant differences in the frequencies of both variables. That's how you would write this up. The findings indicated that males were not more likely than females to have a Twitter account. And we put p equals 0.07 because that approaches significance. However, the p-value approached significance, indicating that there are differences between males and females having Twitter accounts, at least in this sample. So that could be, future research recommendation. You might test this hypothesis again with a larger sample. So remember, you can only conduct the chi-square analysis when both of your variables are categorical. It will not work with continuous variables. And when you focus on writing up the findings, make sure that you could get caught up in all four of those squares and talk about each of the squares and how there were differences. Let me just show you what I mean. It's easier. So let's pretend that we did have 0.04. So there were differences. You could get caught up in, well, there were more males than females that had Twitter accounts, but there were more females than males that didn't have Twitter accounts, and you could start wording the way your findings the way you want, and it can get confusing. You don't want to do that. You just want to focus on what the research question was and stick to that, because that's what's important. So that's why this is written exactly which gender was the most likely to have a Twitter account. That's what we're focused on. And we found that there were no differences, but we approached significance. Okay, I have posted an activity on D2L for you guys to practice this. Hopefully it won't take you too long. This chi-square statistic will be on the final exam, so it's important that you know how to do this. That's all I got for now. Good luck. Okay, I lied. I had one more slide. So I not only do I have this on D2L, but I've added it here. So what you're going to do is, this is the data that I've provided you regarding gambling and student loans. And you guys will complete an Excel file like I just showed you to calculate the statistics for this problem and then write up the results. And then you'll submit that Excel file to the Dropbox. Okay, now I really am done. Okay, bye.